All right, so today we're gonna work on functions. We have g of x is equal to square root of 8x. The question says determine each x value, whether it's the domain of g or not. Well, in order for us to do this, we have to plug in -1 for variable x, which we'll get 8 times -1, which this will give you the square root of -8. And we cannot take the square root of -8. So this one is going to be not in the domain. We'll repeat the same process over here. We'll plug in the 0 for x, 8 times 0, which this will give you the square root of 0. And the square root of 0 is in fact just 0. So this one is in the domain. And we'll do the same thing here. This will be 8 times 2, which just gives you square root of 16. And we can take the square root of 16, which is just 4. So the second one is also in the domain. So my answer for this one is going to be not in the domain, in the domain, in the domain, and check your work, and then we'll get it correct. All right. So let's take a look at number 2. Number 2, they give you the function k of x is equal to 6x plus 100. All we have to do is really plug in what x is. X is over here is actually -5. So we're going to plug in 6 parentheses -5 plus 100. We'll multiply 6 times -5 gives me -30 plus 100. We combine both of these values and we have a value of 70 at the end. So the answer for number 2, when x is -5, k of -5 is actually going to be 70. Let's look at number 3. Number 3, it says, what is the range of g? Now, this is important because when it talks about range, it only refers to the y values. So the range, okay, it goes from 9 all the way down to -4. So the range, if we take a closer look, all right, from -4, which is here, all the way to the +9. So your answer here, when it talks about the range, remember the range is all values of y. The domain is all values of x. So if it talks about the range, a good thing to do is just to make a line and say what, it goes all the way to up here and all the way down here. So my answer is going to be -4 all the way to +9. So let's take a look at the next one here. Let me clear that off. All right. So what is the relative maximum? All right, the relative maximum are the maximum points of the graph. Let me put this in the Basura. Okay. You have a relative maximum, relative minimum. Let me see if I remember this one. There you go. All right. The house numbers on certain street go from 1 to 88. The function b of n models the type of the building whose number is n according to the following key. Which number type is more appropriate in the domain of B? Choose one answer. What is the appropriate domain? So let me read this one more time. A house numbers on a certain street go from 1 to 88. So it goes from 1 to 88. The number B models the type of the buildings whose n according to the following key. So we think about integers and we think about real numbers. Guys, real numbers can consist of fractions, decimals, which is pretty much the same thing. So you're not gonna see on a house number decimals. You're gonna see just actual numbers. So it makes more sense for it to be integers. All right. Now it says, what is the appropriate domain? Well, the appropriate domain, it tells you here, okay? It tells you here that the function b of n, what is the type of the building whose number is n according to the following key. We know it's integers, function, output. So it goes from 0, 1, 2, 3. Let me see. What is the appropriate domain? So the appropriate domain is, let's see, the host numbers uncertain go from 1 to 88. The function b of n models type of the buildings whose number is n, b of n. So this right here is going to be b of n. Over here. What's appropriate? This will be the domain. Go from 1 to 88. Function output. Whose number is n, whose number is n. Okay. Let's go with this one. And the reason why I chose that one, guys, is because b of n, it's actually the output. So we know that's the y, right? So if you look at this one here, b of n, it would have been 0 to 3, which is here, 0 to 3. This one has nothing to do with it, 1 to 3. So the other one is from 0 to 88 and 1 to 88. Well, the first one tells you the house numbers on certain street go from 1 to 88. Even though they're not given over here, there has to be an input for it. All right. Let's look at this one here. It says for a given input value b, I don't know what the value b is going to be, the function g outputs a value of a to satisfy the following equation. Write a formula for g of b in terms of b. All right. Okay, so if we think about this for a second, all right, and if we want it in terms of b, all right, so if we want it in terms of b, let's solve for b. So we have a minus 7 is equal to 3 parentheses b plus 2 divided by 3 this will cancel out. This will be a minus 7 over 3 is equal to b plus 2. Finally, not this, we go back. Subtract by 2, subtract by 2. So this will be a minus 7 over 3 minus 2 is equal to b. So it says write a formula g of b in terms of b. So in this case, it's actually in terms of a. So we got to go ahead and change all of that around. All right. Got to change all of that around. It doesn't let me do it. All right, let me go ahead and erase that again. So, all right, let's try this again. So, solve for A minus 7 is equal to 3 parentheses B plus 2 at 7. At 7 cancels out. A is equal to 3 parentheses B plus 2 close parentheses B plus 7. And this is what we'll enter over here, guys. So here we'll have 3 parentheses B plus 2 plus 7. Now, I want you guys to understand, remember I solved for A and then I solved for B, right? Well, if we think about this, remember this part right over here, this is the clue, okay? If we see a G of B, we need to make sure that the equation that we're gonna have has to have a B in it. For instance, if I give you 2, G of 2, that means I need to plug in the number 2 for the variable B, correct? Do I have a B here, yes or no? Yes, and then the other one that I did, which I saw for B, I didn't have a B, I had an A in the equation, right? So that wasn't gonna work for me. I needed to make sure that the B is in there so I could go ahead and substitute it back into the equation over here, all right? So that's the difference. I had to work both of them, I had to see it, and then I had to adjust it again, all right? So let's take a look at this one over here. We have -3 times the function of -8 plus 7 times G of 2. So according to this, we got 2 graphs here. So we have -3 times f -8 plus 7 times G2. Now, remember what I said, guys. Look, remember when I said this, when I say f of x, that refers to the y, correct? Well, in other words, what this is telling me here is when y is equal to -8. That's what's telling me. And this one is telling me when y is equal to 2. Okay? So, but in this case, we're looking at when y is equal to -8 when we have the function of f, which is the blue one. So if we're going to take a look at the blue one, so this is, we're going to replace this here, guys. So we're going to have -3 times, what are we going to replace it? Well, this is -8. Okay, when x is -8 right here, we're going to have, I think that's -2 right there. Okay. I'm sorry, not this. When x is equal to -8, I'm sorry. -8. Okay, we want to find the y. All right, and the same thing goes here when x is equal to 2. So here, when x is equal to 2 on g of x, okay, when x is equal to 2, I want to say this is plus 7 times -4. It looks like it's good to me. This right here is -2, and this one here is -4. So we could work this out from left to right. 3 times -2 will give me positive 6 plus, since we're dealing with order of operation, we have to do multiplication. Then we have to do multiplication over here. 7 times negative 4 is negative 28, right? Negative 28. And then we combine those two, which gives me negative 22 as your final answer. So far, so good. Like I said, this video is going to be for you guys so you guys could see it, and you could fast forward, rewind it whenever at your leisure, right? So let's look at the next one. So here again, what is the domain of G? Well, the domain of G are the possible values, okay? So if we think about this for a second, it says all real values of X such that X is not equal to 0. Well, can X equal to 0? The answer is yes, it can equal to 0. Because if we think about this, 8 times 0 is actually going to be 0, which is going to be just 0. It says all real values of X such that X is greater than 0. This works, right? Can it be 1? Yes. Can it be 2? Yes. Can it be 3? Yes, because if I take this here, let's say 2, this will give me square root of 16. And what's the square root of 16? 4, right? So this one works as well, but let's see if we have a better answer, okay? All real values of X such that X is not equal to 1 over 8. Well, if we think about this here, we have 8 times 1 over 8. It's the same thing as saying square root of 1, which is the same thing as 1. Okay? That's correct as well. It says all real values of X such that, so it says cannot equal to 0, which it can equal to 0. All real values of X such that X is greater than or equal to 1/8. Well, 1/8 works, okay? So notice, guys, this one here gives you better opportunities. This one, it says all real values of X. Well, this one we could eliminate it. And the reason why we could eliminate it, because we cannot have, let's say when X is equal to negative 2, okay? Well, when we put X is equal to negative 2, we have 8 times negative 2 is equal to square root of negative 16, which this will not work, okay? This will not work. So according to this one will work. This one is not going to work. And this one will work as well. But if you look at between B and D, it says X is greater than 0. Isn't 1/8 less than 0? Yeah, right? So according to this, I see the better option will be actually D. Not D. Let me see, B. Let me see why. All real values of X, all real values of X, and it says X is equal to 1/8. Did I miss something here? Let me see. All real values of X such that X is greater than or equal to 1/8. It is 1/8. It could be 2/8. It'd be 16 over 8. It'd be 3. What is the domain of G? Okay, that's why I know why. I messed up, guys. Because if I plug in 1/8, we start off from where? 1. And if I plug in 0, we actually start from 0. So we didn't get the point of 0 on there. Did you guys understand that or no? Yeah? Okay, let me explain it again. I made a mistake. So if we plug in 1/8, right, to this equation, we have square root of 8, and we plug in 1/8. Okay, let's think about the number line. If we think, oh, that's an ugly number line. The number line, let's go zeros over here, right? If we take this right here, the 8s will cancel out. We're left to the square root of 1. So we're going from here, 1, going in this direction, which is true. But this one here is a better one. Why? Because it takes 8, when it said when x is greater than or equal to 0, take 0 here. This will give me 0. And we take the square root of 0, and the answer is yes. So it goes from here to here, including the 1. But it also includes the 0. The 1 does not include the 0. That's why this one's not the correct answer. All right? You got it? Okay. So I was saying that as a positive reminder, but it's actually multiplication. All right, so that's down right there. So let me go ahead and go to the next question. All right, so it says, baby Kana's parents measure her height every month. So here we could think about the table here, where this is T, and this is H of T. All right, every month. HT models the height of the centimeters when she was T months old. So this is T months old. So this means at 160 months, okay, at 160 months, she was 150 centimeters. Do you guys see that? So at 160 months, okay, she was at 150 centimeters. So when Kana was 150 months, no. Kana had the same height at 150 months old and at 160 months old, no. When Kana was 160 months old, her height was equal to 150 centimeters, and that will be your answer right there.
You know what I realized? Parents who are usually like first time parents only count for months, so this would be like any first time parent.
You should count for years as well. So
First child, they always do it precise.
First child always gets the most presents, remember?
Yes, my sister, my mom, literally. Oh.
Okay, so let's take a look at this one here. It says, select the interval where G is positive. Now, here, they're not saying G of X. Look at the options that are given here. If you look at the options that are given here, they're looking at what? The X, right? So it says 1 or 2. So we have 1 to 2. It is positive. We go to 3 and 4. This is negative. We go from 4 to 5. It is negative. So this is positive, negative, negative. And that's it. So it says, select the interval where G is positive. It's just going to be the first one. Good? All right. 11. It says, select all input, okay, for which H of X is equal to 2. In other words, we have to think about 2. Is it going to be X or is it going to be Y? What do you guys think? It's going to be Y. So we're going to go here, guys. We're going to think about this line here. And we're going to say when Y is 2. It's here. So this is the Y value. It's actually going to be what? 4. And I don't think there's no other ones. I think 4 is the only one. Because at 6, it's going to be at 4. And the other option is at 0. At 0, you do have variables. You have 2, -2, -3, and you have a variety of them. But that should be your final answer right there. All right, it says, Vera made a rectangle using a string that is 40 centimeters long. AW models the area of the rectangle in square centimeters as a function of the rectangle's W in centimeters. Match each statement with the feature of the graph that most closely corresponds to it. Okay, there's a lot of words there. So let's take a look at what options are given. All right, resume again. Okay. So x-intercept, so we can move this around, okay? Relative maximum or minimum, increasing or decreasing, okay? So Vera made a rectangle using a string that is 40 centimeters long, all right? AW, which is this here, models the area of the rectangle, okay? Models the area of the rectangle. In square centimeters as a function of the rectangle's width W. So as the width increases, the area increases. But as the width becomes more larger, the area gets smaller, okay? So the area, I believe, will be the maximum value will be here at 10. So the ideal area, okay, for this right here is going to be when W is equal to 10. If you have a smaller width, you have a smaller area. If you have a larger width, then you have a smaller area, okay? So this is important. Smaller it means what? Smaller area. Larger width also means what? Smaller area. So if we take a look at this part here, let's look at the information that's given. Well, the x-intercept means what? When the width of the rectangle is 27, it has no area, right? We know that. Or when it's actually 0. So we know that's the x-intercept is actually here, all right? When the width of the rectangle is 20, because it shows here this is 20, remember? This is the x-axis or the x-intercept right here. Is 20, it has no area, which is right. The relative maximum, as the width of the rectangle is extended towards 10 centimeters, the area of the rectangle grows, which we said it was here, which is true. This is the biggest part right here, right? And then increasing or decreasing, the greatest possible area of the rectangle is 100 square centimeters. Well, yes, it is true. It's right here. That's the part of that is increasing over here. So as the width of the rectangle is extended towards 10 meters, the area of the rectangle increases. I want to switch these two around. The relative maximum is actually going to be this point over here at 100. Okay. These are the two that should probably be, let me see. The greatest possible area is 100 square centimeter. That should be it. All right. So this one, like I said, the wording is the one that we had to just practice on over here, okay? So let's go to the next question. All right, f of 2. So what does this mean, guys? When it says f of 2, what is it referring to? Anyone?
What?
Well, when it says f of 2, it means when x is equal to 2.
So it's what? Right?
So when x is equal to 2, we have x is equal to 2. What is the answer? What is it? Negative 2. So remember, when you see this right here, f of 2 means when x is equal to 2. So you go where x is equal to 2 and figure out where the answer is. This is going to be negative 2.
So it's the Y.
Yeah.
That's what I said.
No, I said, what does 2 mean inside here?
Oh, I thought you said what is F?
I'm sorry. Okay, I misunderstood. So, all right, that's good. Let's look at the next one. All right, again, what does the price of the pack, when does the price of the pack increase faster? So between 4 and 10, between 10 and 12, the price increases at the same rate over the both intervals. Well, I like what it says here, guys. The price increases at the same rate. You guys learned this before. It's called rate of change.
It's
When you think about the rate of change, what are you thinking about?
the rate.
There you go. You're thinking about the slope, correct?
Yes.
You guys know how to find the slope. How do you find the slope? Very good.
I know the answer.
M is equal to y1 minus y2 over x1 minus x2, correct? Well, these are all coordinates. The first coordinate is what?
12,
4, 12,
10, 25, and 40, 20.
10, 25, and the third one is what?
12, 28.
12, 28. We could find out the rate of change for each one from here to here and from here to here, because it says between 4 to 10 or 10 to 12. Well, if we take the first one, 25 minus 12 over 10 minus 4,
6,
what is that one?
13 over 6.
13 over 6, right?
Mhm.
And we could take the next one, which is what? 28 minus 25
5
over 12,
minus
10, which gives you what?
3 over 2.
This is a 1.5.
And that is
And well, this has to be 2 point something, right? Because if it was 12, it'd be 12 divided by 6, it would be 2. So this has to be 2 point something, even if we don't know what the something is.
it's still large.
So which one is the greatest increase? A. There you go. So notice how, guys, you bringing things together. You talked about the rate of change, and it says which price increases faster, etc. So a couple of things you have to know about, which is when does the price of the pack increase faster, and the information that is given over here. Okay. Next question. All right. So this is one that I need you guys to please listen up. It's not that hard. Ready, guys? This is the inverse of the function. When you talk about the inverse of the function, all right, it means, you see this function over here that's given? Remember, f of x is equal to, I'm gonna write this down, so I'm gonna do it, f of x is equal to 8x plus 1. I told you guys you could see as f of x as what again? Y, very good. So we have y is equal to 8x plus 1.
plus 1.
Okay, so here we go. Here goes. This is how easy it is. If you see the negative inverse, okay, f of -1, what you want to do is you want to change, you want to go ahead and change the x for the y, and you want to rewrite it. So this is what I'm going to have. X is equal to 8y plus 1. And now we're going to go ahead and solve for y. So in order for me to solve for y, what do I have to get rid of? How do you get rid of the 1? Subtract 1. What you do to one side, this cancels out. So now we're left with x minus 1 is equal to 8y. This is what stuff that we've been doing every morning, right? When you come in, well, every afternoon, when you guys come in, we solve for a specific variable, right? This is actually easier than what we've been solving, right? This is actually college algebra, guys. So guys, what is the next step to solve for y?
Dividing it by 8.
Very good. Divided by 8, divided by 8. Guess what, guys? You guys are done.
Wow, that's simple.
This right here goes in here. So let me go ahead and plug that in. That's the inverse. So here we go. Let me go ahead and put this here first. X minus 1 on top, and the denominator is 8. That's it. All right.
That's pretty simple.
Next question. All right. It says, Erica chops wood in the forest. The table compares the number of cans and insect repellent Erica uses, the number of mosquitoes bites the number of mosquito bites she gets each day. Can the mosquito bites be represented as a function? Well, remember, in order for it to be a function, the x cannot repeat. Does it repeat?
Yes.
It repeats here and here,
And
but
with the 4s.
but is it the same? So for instance, if you look at this, this is really what? 2, 2, 9. Are they really changing? No, it's the same, right?
Yeah, and then also with the 4, 5, 4, 5.
4, 5, and 4, 5. It's still the same.
Since it's the same outcome, does it mean it's the same thing?
Exactly. Since it's the outcome, it's still the same thing. It's a function. Now, if this, for example, the answer here is it a function? The answer is going to be yes, because it's still the same. But now let's say if instead it wasn't 2, 9,
It was 2, 7.
2, 7 or 2, 8, whatever, then this would have been not a function.
Okay.
But be careful. And the reason why we're trained to think, oh, we see the x's twice, boom, it's not a function. But we don't stop and see, is it the same numbers? And I'm guilty of it because it happened to me, okay? So in this case, it is. There you go. All right, let's look at the next one. We're almost done. We got 1, 2, 3, like 7 more, 5 more. It's like, I don't know. Okay. Select the interval where h is increasing. Well, let's look at the numbers. It goes from -4 here to -3. Okay. -2 to 0. It goes from 0 to 2. And it goes from none of the above. What do you guys think? The first one?
Wait.
The question says, select all the interval where h is increasing.
Yeah.
I mean, yeah, for this bit, because let's think about B. If it's B, like little.
Yeah, it would have been lower than, yeah, it's
0 to 2.
it's A.
So
It's
that's why
A.
it's possible elimination.
Is A.
It's A?
Wait. I don't know, when you say it like that,
Oh yeah, I think it is.
it is.
But this is my test, so I'll leave it worry about that.
It is. What? Oh. Huh?
Is it?
It's A. Right?
He said A.
Yeah.
Okay.
Oh my God! Who could do that?
Why do you think it was A then?
Because like I said,
Because it
when it's
goes-
decreasing, everything else is increasing.
Everything else was like going in a staircase and then
It's going
just
up.
drops
Negative
all of a
two.
sudden.
To zero, you see that going up. Same
It's
thing
going
with
up,
zero
and then
to
0
positive two.
to positive 2, it's
The
going
only
all
thing
the way
that
up.
isn't is the other one.
Say, repeat again one more time.
And look. Look,
Uh-oh.
from here to here, it's increasing. That's obvious. You know, normal will tell you different. Same thing with that one. This is the only one that's decreasing, it's going down. See it there? It's going down.
Good job.
Um,
All
when
right.
you were saying it, you're making me doubt it. And I knew it was the right answer.
It says, mark the absolute maximum of the point. You have what's called a maximum and you have what's called a minimum. The absolute maximum, it is the highest point of the graph.
It's that one. It's 5. Where is it? -3.
So there's a difference between relative maximum and the absolute maximum.
Relative is it
Relative means all the possible highest points. Absolute just means the highest point.
It's -3 and 5.
Well, it says maximum. So notice the difference. There's one that I did earlier had the word relative in it.
Yeah, it needs to be all.
So think about, like, when you think about it, think about hills. Well, I got one hill here, I got another hill over here. Like this case, this would have been, I got one hill over here, I got another hill over here. These two would have been the relative maximum. You guys understand that? But because of the word the absolute maximum means the highest point. You also have absolute minimum,
It's the smallest of all.
the smallest of all the points.
Is there a relative minimum?
Yeah.
Oh, okay, so be all of this.
Mhm.
Okay.
Okay, so now we have this here. It says h of what number will give you to be -5? Well, we already know that this whole thing means y, right?
Mhm.
And we know that whatever we put in here is going to be an x value, correct? So according to this, we could rewrite this as -5 is equal to x minus 11. So we could go ahead and solve for x, which was what? Add 11,
Plus 11,
add 11.
6.
When x is equal to 6,
Wait, so that's the answer?
yeah.
Oh my.
When h of 6, when x is equal to 6, we're going to have it as -5. Remember the table that we said before, right? When we have x and we have h of x, right? Well, the same concept. Whatever goes in the parentheses, the x value, right? Well, we said 6. When x is 6 here, when we plug in 6, it's going to give me the output of -5.
That's pretty simple.
Okay.
Mhm.
6. So let's take a look at this one here. This one's not that bad because on this one here, guys, I want you guys to understand something. This is just doing the inverse. In other words, guys, ready? Now, remember before, if I gave you this, guys, f of x, or let's say if I gave you f of 18. Guys, what is f of 18?
Y.
Look at this. When x is 18, what is the y?
-1.
-1. Do you guys see that?
Mhm.
If I give you this, f of 5.
9.
Very good. Now, this, guys, is just a complete opposite. Instead of going like this, now we're going like that.
So then,
So when we have f of -1, -2, what's it going to be an answer?
3.
3. What would this one be then? You got it. So this right here.
It seems like it would be hard, but it's really simple.
Okay, what confuses a lot of students is that like these functions, see it as a new language. But this is how it goes. Ready? If we do some today, do some the next day, do the sum the next day, The only way this is gonna get easy for you is if you do it again and again and again and again.
Practice.
And then you practice it, it's gonna be easier. Like I said, I'm not a miracle worker, guys. You need to do your own part. I think honestly, this is the longest one. There's 22 questions on each on this one right here. If we do it today, tomorrow, you're gonna have it mastered by the end of the week. We're an easy 8. And like I said, they're not that hard, guys. So let me go ahead and put, so you said when it's -2 is actually 3, and this one is gonna be 0. Check. All right, let me clear that out. So we have that over which interval does H have a positive average rate?
Yeah, go ahead.
2 to 3, -5 to 3,
Wait, that's not even one of them.
0 to 1, or -3 to -1.
Wait, are these supposed to be that are up there? Because none of the other ones are up there except for. Wait, no, wait, can you
Yeah,
scroll
they
up?
are.
Wait, no, none of them. Oh,
2 and 3 on two.
none of them are up there.
-5, 3 is up
Yeah, they are. Look over here on this side.
That's -5 and 6.
Yeah, so you're going 2 to 3. So let's take a look at this. When we go 2 to 3, does this have a positive? Yes or no?
Oh, that's what it means.
So from -5 to -3, going here, does this have a positive? Yes or no?
Yeah.
This is negative. Let's look at the next one.
I get it now.
0 to 1. So let me erase. I don't want to erase that. So 0 to 1 right here. Does it have a positive or negative? Negative.
Here,
And let's look at the last one.
-3.
-3 to 1. So we go from -3 to 1. Negative.
Should be the first one.
It should be, unless I'm wrong.
Mhm.
All right, we got one more to go.
So don't get it wrong.
All right, let's get it wrong.
Better not.
Does a graph represent a function? That one should be easy.
No, it doesn't.
Why not?
Because it
Because
passes
it
the vertical
goes
line test.
down.
You need to have a vertical line test, guys. If the line would have been like this, then yes, it would have been 1 to 1, because if we do a vertical line
One of
test,
the numbers will always be there.
remember the vertical line test goes like this, right? If I do the line here, it actually goes on the line. So automatically that does not comply with the vertical line test, because all the points will be on the line. So the answer to this one is
They don't
no.
have it.
Let's
All right.
put yes just to get it wrong.
No, don't even think about it, Mr. Coulson.
You came in.
We only got one wrong.
All right. So I'm gonna end up this here so you guys can know, so you
We
guys
just
can
went
practice.
From 5% mastered to 50% mastered on this.